Stop, it rained for 2 million years, and it's starting again. It didn't just rain, it rewired the planet. Identical clay-rich mud shows up across basins an ocean apart. Volcanic ash locks the dates. Mercury spikes shout the source. Oceans go dark, then life surges in new forms. If that same lock engages now, our maps, farms, and power grids don't just struggle, they fail. So what on earth triggered rain that didn't quit for roughly 1 to 2 million years, and is the mechanism priming again? Today we trace the trigger, the loop that fed it, and the signals flashing right now. Hold on. First rock clue, stone to air, a line you can follow. The day the clouds never left. Start with a slab of soft gray rock you can hold in your hands. Thin black laminae you can count like tree rings. In one quarry, a quiet lake bed. In another, a shallow shelf. Different worlds, same thin clay, same sudden switch to darker, oxygen-poor layers. And tucked inside, the same whisper of volcanic ash. That match lets geologists snap distant outcrops together like a zipper. Then the Mercury hits, tiny but unmistakable, spiking right where the layers turn wet. Different basins. Same story. Here's the world before the flip. Late Triassic. A supercontinent, Pangaea, stretches pole to pole. Big land, big heat, big drought swings. Monsoons lash coasts in short, violent bursts. Interiors bake, then flood, then bake again. Rivers run braided and dusty. Lakes shrink to pans of salt. Plants hug low to the ground. Reptiles rule scrubby flats and seasonal rivers. That's the baseline. Then the shift. Lakes swell and do not recede. Deserts drown under repeat deluges. Shallow seas turn black as organic muck piles up faster than oxygen can chew through it. In core after core, fine couplets build, light, dark, each a year. Each a reminder the rain returned on schedule and stayed. Some places record the bottom dropping out of oxygen. That's an ocean going breathless. So what flips Earth from bursty to locked wet that long? Evidence stacks. Lake varves thicken and regularize, showing sustained runoff. Clay minerals pivot towards smectite, the swelling kind that forms with persistent moisture and intense weathering while illite fades. Pollen jumps and shifts. You see fern spikes just above the wet turn, classic signals of disturbance and rapid colonization. Conifer pollen rises too, pointing to forests expanding into soggy ground. Carbon isotopes swing, with multiple sharp negative excursions, the signature of big injections of light carbon into air and ocean. Losers fade from the record. Dryland specialists thin out. Some reptiles tied to episodic rivers and open scrub decline in trackways and bone beds. Wetlands, though, explode. Turtles, early crocline forms, and semi-aquatic generalists start leaving more marks. You can read diet and habit in teeth, limbs, and mud. So yeah, weather changed. But the ash and Mercury fingerprint points past weather toward an engine. You find layers with volcanic glass shards altered to clay, and right alongside them, Mercury to organic carbon ratios jump in step with carbon isotope drops. That pairing repeats across the western Tethys, South China, even high latitudes. It's not one storm, it's pulses. The planet's carbon cycle lurches, and each lurch lines up with a bump in volcanic fallout. And here's the thing, single eruptions fade in a year or two, yet the rain didn't. It kept finding a way back again and again, long enough to stack meters of black shale and clay-bound silt. That tells you driver plus amplifiers. Think ignition and then a feedback that catches. Picture the land. Fresh volcanic carbon dioxide nudges global temperature up. Warmer air holds more water. Oceans, already warm, toss more vapor into the sky. Monsoons bite deeper into the continent. Soils stay wet longer. Darker, damp surfaces soak more heat, kick up more afternoon storms. Smectite forms as rock breaks down fast. Rivers shift from flashy to fat and brown. Year by year, the signal becomes a season that doesn't end. In the air, sulfur-bearing aerosols from eruptions seed more cloud droplets. That can brighten clouds and cool for months, but it also loads the sky with condensation nuclei, the grit raindrops need. More nuclei means slower coalescence, taller anvils, and storms that sit and dump. Over warm land, that's a stall. Meanwhile, the oceans. Nutrient pulses from land drive blooms. Blooms sink. Oxygen crashes near the seafloor. Black shales lock in carbon that used to cycle back fast. That burial can, over time, trim greenhouse levels, but not right away. Short term, the warmth and rain feed each other. All of this starts to look like a threshold behavior. Get enough carbon dioxide, enough warm water, enough aerosol seeding, and the circulation can park. Convergence zones slide and then hesitate over heated interiors. The winds weaken, the jet kinks, and storm tracks stop migrating. Now every day's weather writes another line in the same book. So the central question stands, sharper now. What was the deep engine that made these identical muds, these mercury spikes, these black oceans, and kept the hydrological cycle locked to wet for on the order of 1 to 2 million years? The stone says volcanism lit the match. The layering says something else kept feeding the flame. Follow the fingerprint, ash, mercury, carbon isotope drops, tie those to specific times. Across Italy's Dolomites, Austria's limestones, China's basin lakes, the signal repeats. Even in high-latitude soils, you see humidity markers and matching chemical swings. It's a global pattern, not a local quirk. And that pattern is your bridge from rock to sky to system. Because once you see that bridge, you can go looking for the engine by name. And the name shows up where the ash began. Wrangellia, a large igneous province that erupted in pulses off what is now western North America. Mercury spikes match volcanic fingerprints. Carbon plunges align. The clock starts there, and the clouds never really left. The ash and mercury fingerprint, naming the engine. So we pull the thread you can actually see. The ash gives us time, the mercury gives us source. In section after section, the same story shows up. A thin horizon where volcanic glass is altered to clay, and right there the carbon isotope curve nosedives. At that exact pivot, mercury to organic carbon ratios jump. Not a gentle rise, spikes. Western Tethys shelves, South China lake beds, even high-latitude soils. Different settings, same choreography. 4 major pulses, 4 carbon plunges. 4 humid swings that follow. That is not weather, that is pacing. Mercury matters because volcanoes love to ship it. Elemental mercury rides the wind for months, then rains out across entire basins. Rivers can move a local load, sure, but not in perfect sync on 3 continents. And the mercury's isotopes come with a tell. During peak spikes, mass-independent fractionation trends toward values expected for volcanic sources, not some oddball photochemical quirk. That is the sky signing its name. Okay, name the engine. Wrangellia, an oceanic plateau built by flood basalts erupting into the Panthalassic Ocean, later welded onto what's now western North America. Geochronology bracketing those lavas lines up with the late Carnian. Biostratigraphy agrees. And get this, the pulse structure people infer for Wrangellia, bursts rather than one long ooze, mirrors the mercury pulses tied to the carbon dives. The zipper closes. Ash shards for timing, mercury for source, carbon for impact. What did those eruptions actually change? First, greenhouse load. Carbon dioxide pours out, adding light carbon to the system. That matches the negative carbon isotope excursions. Second, short-lived sulfur species reach the stratosphere. Those brighten clouds and briefly cool surfaces, but they also explode the count of condensation nuclei. More seeds, finer droplets, delayed rainout, taller anvils, longer-lived storms. Third, metals and ash wash back to land and sea. Rivers turn brown and strong. Shelves bloom, crash, and go breathless. Black shales start writing receipts. But here where the but therefore chain locks in. Aerosols cool surfaces for a season, therefore temperature gradients wobble and jets kink. But carbon dioxide stacks and methane likely joins, either straight from the mantle or from baked organic-rich sediments and destabilized hydrates as seas warm. Therefore background heat rises for decades. Warmer oceans pump more vapor, therefore monsoons shove farther inland and stall more often. And because eruptions pulse, the system never resets before the next shove. Each shove finds the sky already humid, The soil's already dark, the sea's already steaming. So the wet mode comes back like muscle memory. Constraint check. Individual eruptions fade fast, months to a couple of years for the aerosol veil. Yet the humid phases outlast those veils and return in step with the carbon dives. Therefore, amplification had to come from Earth's own plumbing. Weathering indicators jump smectite up, lithium isotopes hinting faster silicate breakdown. That's rain hitting fresh rock hard. Weathering on basalts pulls down carbon dioxide on thousand-year scales, but in the near term it floods rivers with ions and fines that seed clouds and darken ground. Land cover flips, fern spikes right after disturbances, then conifer pollen swells as gymnosperms build canopy. Forests leak water back up and roughen the surface, making clouds easier to pop. Oceans stratify, store heat near the skin, and fuel thicker atmospheric rivers. The amplifier is the water cycle itself. Open the methane side carefully. The carbon isotope plunges are big. Volcanic carbon alone can struggle to hit that amplitude unless you add a secondary store. One theory: contact metamorphism bakes organic-rich sediments where sills intrude, venting light carbon. Another: warming shoals destabilize methane hydrates in slopes, adding short, sharp bursts. We cannot weigh each gram from 230+ million years ago, but the pattern fits. Pulses of light carbon on top of volcanic forcing, each followed by humid swings. Mark that as a strong inference, not a courtroom fact. Cross-basin consistency seals the case. In alpine sections, carbonate platforms shrink and fragment as runoff and acidity cut clarity. Black shales stack exactly where Mercury spikes. In South China, lake levels jump, oxygen drops, and clay mineral flips track the same horizons. Even pelagic muds out in Panthalassa whisper the timing in tiny glass and trace metal anomalies. The same 4 beats, the same tie to a named large igneous province, the same climate switch that follows. So why does Mercury earn so much airtime? Because it frees us from arguing about local rivers and quirky lakes. Mercury falls out from the sky. When its spikes walk hand in hand with carbon isotope dives and ash clocks, you get a global baton. And when Mercury isotope chemistry leans volcanic during those peaks, you stop chasing ghosts. Wrangellia is not a shrug, it is the match. Now stitch ignition to habit. Eruptions supply carbon dioxide, sulfur, ash, and trace metals. Therefore the air warms, the cloud microphysics shift, and storms slow down. Therefore soils saturate longer, weathering accelerates, and rivers feed shelves until they choke. Therefore black shales bury some carbon while the surface ocean keeps steaming. Therefore the next pulse lands on a primed system, and the wet mode snaps back faster. Across 4 main pulses, that becomes a 2-part score, a geochemical pulse and a hydrological echo. And here's the kicker: you do not need a new law of physics to keep rain coming. You need pacing and a supercontinent's leverage. Wrangellia gave the pacing. Pangaea supplied the stage. Orbits likely nudged timing. Mercury let us watch the conductor's hand. Once you accept that, the rock stops being a mystery. It reads like a logbook. We've named the engine and mapped the shove. Next, we sit inside the sky and watch it flip state, droplets, updrafts, and stalled lines, because that's where persistence lives. The air changed state, chemistry to cloud physics. So let's climb into the sky and watch the switch flip. Start with carbon dioxide. Each volcanic pulse lifted the floor. Warmer air held more water. Water vapor trapped more heat. That is a quiet compounding. Every gram of vapor also carried latent heat, which cashes out as buoyancy when clouds form. More latent heat, easier lift. Easier lift, longer-lived storms. That was the canvas. Now add methane. Some rose with deep gases. Some likely vented from baked organic rocks and stressed hydrates on warmed margins. Methane is short-lived but strong. It stacked a decade-scale boost on a rising carbon dioxide floor. The lower troposphere got warmer and wetter between pulses. Storms spun up on background fuel, not just single sparks. Sulfur changed the microphysics. Eruptions lofted sulfur dioxide high, where it turned into sulfate haze. The veil reflected sunlight and cooled surfaces for a year or two. But get this, those same particles are prime cloud seeds. More seeds mean more smaller droplets. Smaller droplets collide slower. Rain is delayed. Updrafts hold on longer because they shed less water weight early. Anvils grow taller and wider, so you could have a slightly cooler surface month with storms that sit and reload. The veil faded, but the seeding habit kept echoing as long as the air stayed wet. Drop to the boundary layer. Warm seas kept feeding vapor. Over soaked soils, more sun went into evaporation instead of sensible heat. That meant afternoons launched plumes with free lift from latent heat. Released high, that heat supercharged updrafts. Stronger updrafts built thicker anvils that shaded ground and weakened pressure gradients. Weaker gradients meant storms moved slower. Slower storms rained on the same ridge or valley all afternoon. That is how you write identical laminae year after year. Fresh weathering joined in. Hot rain on new basalt broke rock fast. Rivers carried ions and fine clay. Some ions built secondary aerosols downwind. Some fines darkened surfaces and sharpened local heating. Dust and ash added larger nuclei that catalyzed ice in cloud tops. Mixed with sulfates, that cocktail made glaciation aloft easier. More ice meant more hail embryos and efficient precipitation once the switch flipped. But because the droplets started small, that flip came late and hard, right over the same line. Monsoon mechanics locked it in. Warm land drew marine air. If soil stayed wet, mornings primed vapor without building a strong cap. Cloud bases formed low. Early convection did not slam the door, it just moistened the column more. Day after day, the front shoved inland and then hesitated over terrain. Mountains squeezed water from every parcel. Valley winds and sea breezes met along the same boundaries at dusk. The line retraced night after night. Zoom tighter into droplet physics. With high cloud condensation nuclei, cloud fields looked puffy and bright, but they withheld rain. Collision coalescence, the droplet growth process, lagged. Updrafts recycled parcels along gust fronts. Lightning spiked as charge built in tall, glaciated towers. When rain finally formed, it fell into air already near saturation. Evaporation could not cool downdrafts much. Cold pools spread but stayed moist. Instead of killing nearby updrafts, they lifted them. That is training, storms rebuilding on their own outflows. Layer in atmospheric rivers. Warm pools in subtropics and tropics launched narrow, deep plumes of vapor along pressure corridors. If the jet weakened and kinked, those corridors parked against the same mountain walls. On a supercontinent, fetch was huge and rim ranges tall. Plume wobbled, but it kept hitting the same slope. Nighttime land breezes and canyon jets stacked convergence. Morning sun relit the whole belt. Copy, paste, flood. Vegetation rewrote the near-surface physics. Ferns jumped in first, then conifers lifted rough canopies. Plants leaked water back all day through leaves. That raised humidity between bursts. Roughness mixed the boundary layer, lowering the lid for new clouds. Earlier cloud start times lengthened daily rain windows. Shaded soils crusted less and infiltrated more, so base flow rose and held humidity in the valleys. Plants became a quiet humidifier that bridged pulses. Ocean structure held the fuel line open. Heavy runoff freshened shelves, capping dense salt water below. Heat pooled in a wafer-thin skin. Skinny, warm skins evaporate fast. With a meandering, weaker jet, wind stirred less. The cap persisted. Nutrients from land flared blooms that sank and stole oxygen below the cap. Breathless water spread. Black mud kept the receipts. Near the surface, vapor stayed thick. The next plume left the dock full. Stratospheric cadence added a twist. Each sulfate veil started bright, cooled, and faded. That cool shot could sharpen land, see contrasts for a season, and juice monsoon inflow. When the veil dropped out, the warmed ocean skin asserted harder. The jet jolted and blocked. Block stalled steering winds. Stall steering plus fat vapor lines equals parked convection. Tie it clean. Volcanic gases raised heat and moisture capacity. Sulfates seeded long-lived clouds. Dust and ash tuned ice and hail. Weathering darkened land and tossed more nuclei into the mix. Vegetation kept the boundary layer humid and easy to flip. Oceans capped, stored heat and fed narrow vapor highways. The jet weakened, kinked, and stopped pushing storms along. None of those alone makes endless rain. Together, they flipped the air into a wet-preferred state and held it there between shoves. That is how chemistry became cloud physics, and how cloud physics wrote rock. The hydrological feedback trap. So let's map the loop clean, because this is where a lot of rain turns into a mode the planet prefers. Warmer seas push harder evaporation. More vapor in the air traps more heat. Warmer air then holds even more vapor. That is the quiet engine. Every extra gram is latent heat you can spend as lift when clouds form. Free lift means storms pop easier and live longer. Heavier rain follows. Heavier rain hits rock like a hammer. It fractures grains, opens pores, and fuels chemical weathering that builds smectite clays. Smectite swells. Soils stay wetter for longer after each burst. Dark, damp ground absorbs more sunlight but turns more of that energy into evaporation instead of hot air. That evaporation loads the boundary layer with vapor that releases heat high up when it condenses. That release powers taller updrafts and bigger anvils. Those anvils shade ground, weaken pressure gradients, and slow storm motion. You get slower storms over a wetter surface. That is the click. Weathering pulls double duty. Over long spans, it draws down carbon dioxide as bicarbonate rides to the sea. That is the slow thermostat. Near term, fast weathering floods watersheds with ions and fines. Ions help make secondary aerosols downwind. Fines darken floodplains and shallow shelves, soaking more sun and sharpening convection in place. More seeds in the air, more afternoon towers. Towers dump on already saturated ground, so runoff turns from spikes to steady brown flow. Base flow rises. Rivers stay high between storms. Humidity stays high over valleys. Another click. Vegetation is a quiet amplifier. Ferns rush in on disturbed wet soils. Then conifers lift rough canopies. Plants pull water up and leak it back all day through leaves. That raises humidity even on so-called clear days. Rough canopies mix the lowest air, lowering the lid that usually keeps clouds from starting. Cloud bases form with less lift. Earlier start times stretch the daily rain window. Shade and litter protect soil structure, so water infiltrates deep instead of skimming off in sheets. Deeper storage then bleeds out as cool vapor and seepage between storms. The land becomes a humidifier that bridges pulses. Rivers stitch land to sea. With fatter, steadier flows, nutrients ride to shelves. Blooms flare then sink. Oxygen crashes near the bottom. Stratification strengthens as fresh water caps warm salt water. A thin, hot skin sits on top, evaporating hard. That fuels nearby atmospheric rivers, making them thicker and more reliable. If the jet is weak and kinked, those vapor lanes park against the same mountains. Storms reload over the same basins. Identical laminae stack. Mud tells you the system learned repetition. Blocking is the door latch. A buckled jet builds a ridge that will not budge. Storms ride the edge. On that edge, downdrafts fall into air that is already humid, so they do not snuff nearby updrafts. They lift them. Gust fronts collide with valley winds and sea breezes and light another line. Trains form. Steering stays slack because the ridge sits. Every day writes the same ink on the same page. Scattered silt turns to thick, uniform mud with few cracks. The rock keeps the score. Thresholds make this nonlinear. Below a soil moisture line, afternoon storms fizzle or drift off. Cross it and downdrafts are moist and weak. Gust fronts are gentle lifts and clouds rebuild where they just rained. One week you have isolated cells. The next, a parked belt. Biotic signals jump too. Fern spores spike right above disturbance. Turtles and crocline tracks multiply where sandbars stop drying. The switch is abrupt in life and mud. Now the brakes, because no loop runs forever. Weathering's thermostat is slow but real. As basalt crumbles, it pulls carbon dioxide down and cools the background over tens to hundreds of thousands of years. Black shales bury organic carbon, trimming greenhouse load on similar clocks. Oceans can reset if winter cooling and winds deepen mixing, dragging oxygen down and busting the cap. Forests can mature into steadier transpiration with smaller midday spikes. Floodplains can aggregate and widen, spreading flood peaks and damping energy. These are breaks, just not fast ones. Pacing matters most. In the Carnian, pulses kept shoving before the slow levers could bite. Between shoves, memory held, wet soils, humid canopies, warm skins, and a parked jet. The system sagged wet, not dry. That is persistence, an atmosphere that prefers wet, reinforced by land and sea. Only when the pulses faded did the long breaks catch. Smectite relaxed. Mercury spikes waned. Varves thinned. Shelf oxygen crept back. Here's the mirror for us. You do not need a million years to feel it. A season with record-warm seas, a weak, blocked jet, stacked atmospheric rivers, and saturated soils can lock a region wet for months to a couple of years. Long enough to rot roads, drown transformers, and wreck planting calendars. If new shoves keep coming, different source, same effect. The loop reacquires faster because the land and sea learn the habit. So the move is simple to say, hard to do. Lower the fuel so jets strengthen and vapor thins. Build sponges, wetlands, forests, floodplains, permeable cities, so water has places to pause without damage. Strip nutrients off flood paths so coasts do not feed the next plume. And watch for persistence, not just peaks. Retracing storm lines, soils that never dry, rivers that stay high, coasts that go hypoxic twice in a month. If those stack, you act early. Because once the sky learns to stay, the ground and sea help it. That is the trap and the map out. Orbits, continents, and a stalled planet. So let's test the loop against the planet's metronomes and bones, because timing and layout decide whether a shove turns into a stall. Start with the beats. Earth's orbit wobbles and stretches on set clocks. Precession flips which season points a hemisphere toward the sun. Eccentricity, with that clean 405,000-year cycle, changes how much that seasonal wobble matters. Stack them, and some centuries lean into hotter summers over land. In Carnian time, those beats lined up with the wet packets. Not day precise, but close enough to tip windows open. Lay that drum over a supercontinent. Pangea is leverage, not scenery. Half the planet is land, with interiors far from any sea breeze. Rim shelves are wide. Summers, the interior bakes because there's no nearby ocean to bleed heat. Coasts bottle moisture along long arcs that face warm water. When a monsoon pulls, the fetch is huge. When it stalls, there's nowhere for that water to go except straight inland, day after day. Geography turns vapor into a machine. Mountains pull a hard lever. Air climbs windward slopes, cools, and dumps. On lee sides, it slumps and sets convergence lines that hang back. If the jet is weak and wavy, those lines do not sweep through. They relight along the same ridge or plain. That is how you stack identical laminae and rerun floods before hills can heal. Now the jet orography becomes in a warmer background with a softer equator-to-pole gradient. The jet weakens and meanders. Blocking highs show up more and last longer. Think of a heat dome that just sits. Storms ride the rim. Over a supercontinent, that rim lines up with monsoon fronts and mountain chains. Instead of belts that march north and south cleanly, you get kinks and stalls. That is how pulses become seasons that will not end. Do the rocks follow those beats? In good sections, yes. Varves bunch into decade bundles, then into thicker packets that match the long eccentricity metronome. Clay minerals wax and wane in steps. Smectite builds through wet packets and relaxes in drier ones. Carbon isotopes ride the envelope, with sharp negative plunges pacing the Mercury spikes and broader swings leaning with orbital phase. It is not a metronome you can hear. It is a rhythm you can trace with a finger through mud. So is this all orbits? No. Orbits set the ESA flip. Wrangellia's pulses still shove. Sulfur seeds clouds, carbon dioxide lifts the floor, oceans warm and cap. But when a pulse lands during a precession phase that superheats land in summer, and during a high eccentricity window that magnifies that contrast, the same pulse bites harder. The wet mode is easier to catch and harder to shake. That is the both then. Timing leans. Volcanism pushes. Geography locks. Flip the timing. If perihelion points winterward for the key hemisphere or eccentricity mutes seasonal contrast, a volcanic shove still warms and seeds, but storm belts sweep more and soils get small resets. Wet packets thin, black shales shrink. The order holds, the amplitude shifts. That spread is exactly what shows across basins. Not every outcrop hits max every pulse, but the staircase is there. There is a slow exit in the map. Under hot rain, fresh basalt weathers fast. Over tens to hundreds of thousands of years, that draws carbon dioxide down. As the background eases, the equator to pole gradient stiffens a bit. The jet strengthens and belts start to march again. In the sea, as organic burial tops off and inputs thin, winter mixing can creep back and oxygen edges across shelves. Later Carnian sections whisper that sag. Mercury spikes fade, smectite relaxes, varves thin, and carbonate platforms begin to breathe again. Now pull a line to us without pretending we live on Pangaea. Continents are split, oceans bracket the mid-latitudes, but the mechanics rhyme. Warm floors weaken jets, blocks park. Atmospheric rivers hit the same mountain walls and unload. Monsoon domains shove inland and hesitate. Orbital phase still modulates seasonal contrast, just across a different map. Catch a few decades where precession favors strong summer land heating for your region. Lay that on record-warm seas and a high greenhouse floor, and you lengthen wet runs and stalls. Not a Triassic copy, but a familiar shape. Add the ocean modes. El Niño shifts Pacific plumes and pushes them poleward on a warm background. The Indian Ocean dipole nudges which coasts get hammered. If the Atlantic overturning circulation slackens, heat release and pressure fields move, bending jets and helping blocks hold. Meltwater freshens polar caps and cements stratification. None is a switch. Together they set rails that storms prefer. City lines and forests finish the echo. Urban heat islands pull low-level convergence and speed runoff, which changes where gust fronts relight. Deforested hills lose roughness and midday transpiration spikes, which can delay clouds but sharpen peak flow when a line parks. Reforested basins leak water back and mix the boundary layer, which can lengthen cloudy windows but shave flood peaks. Across a continent, that patchwork steers where the copy machine runs. So the checklist is blunt. Beats, precession and eccentricity tilt seasons. Bones, continents and mountains focus fetch and force lift. Shoves, greenhouse gases and aerosol shifts warm and seed. Rails, jets weaken and block when gradients soften. If three or more align, rain stops being an event and becomes a habit. In the Carnian, that stack held often enough to write mud and black shale for on the order of 1 to 2 million years. Today, you do not need that span to get hurt. You need one bad alignment, one hot basin, and one block jet that will not move. The stones are not a myth, they are a manual. Extinctions, then open space for winners. So what happened on the ground while the sky learned to stay? First came the quiet thin. Dryland guilds that lived on the old rhythm bake, burst, bake started to slip. Rhynchosaurs, those broad-headed, beak-jawed browsers made for gritty cycads, fade in many basins right above the wet-turn clays. Big dicynodont holdouts, tusked plant-eaters from deeper time, shrink from local lists. Trackways tied to sprint and weight hunters over hardpan go scarce. It is not a curtain drop. It is erosion by habit. Coasts took the first hard slap. Carbonate platforms needed light and clarity. Runoff made milk of the shallows. Acidity nudged against skeletons. Reef builders that wanted bright, still water stumbled. Ammonoids, those thin-shelled, high-oxygen swimmers, took repeated hits where shelves went breathless. Each mercury spike and carbon dive left the same bruise in fauna, stressed, culled, then reset with a tougher cast. Now look where mud keeps secrets. New tracks, new teeth, new grit. Early dinosaurs show up more often, still small and quick, not monarchs yet but stubborn survivors. Three-toed footprints cut neat lines across soggy floodplains that hold impressions because the ground never fully dried. Slender theropods with blade teeth. Basal sauropodomorphs testing longer strides and slightly higher brows as conifers climbed. Not a takeover, a foothold that stuck. Turtles loved this new map. Still water lingered in oxbows. Banks slumped but did not bake to brick. Shells buried soft and survived. Crocline archosaurs threaded the edges, ambush in pools, slow cruise in channels, jaws with room for chance. They were both end animals, comfortable in air and water, hot and cool, clear and turbid. Generalists with lungs to spare wind when the board keeps changing. Plants flip the base. Right above disturbance clay, fern spores spike, classic rapid colonizers filling raw, wet gaps. Then conifer pollen swells and holds. Evergreen canopies take ground that used to crack and glare. Shade, litter, and steady transpiration change the meter-high air, cooler, wetter, calmer. Detritus swells as a food path. Rivers run thick with needles and twigs. Webs lean on what falls, not just what grows in place. Diet shows the pivot in teeth. Browsers that can swap between tough conifer shoots and softer understory fair beet specialists tied to sparse, thorny scrub. Insects that mine litter and wood multiply. Small mammaliaforms with sharp cusps for arthropods tuck into edges under roots and driftwood. Amphibians spread along linked wetlands. Fish with low oxygen tricks. Air gulpers, extractors. Find corridors as lakes stratify and summers stay murky. Shelf life rewired the same way. Each humid pulse poured nutrients. Blooms flashed green, then turned shelves breathless. Picky animals blinked out regionally. Between pulses, hardy builders, sponges, microbialites, stitched small carbonate mounds in quiet corners. Not the old bright water palaces, starter homes. Patchwork resilience that slowly rebuilt architecture. You can date this in bones and mud. Vertebrate-rich beds sit just above the wet-turned clays and first black shales. Mercury spikes lie below. Negative carbon isotope swings frame the base. Then, the faunal turn shows. More trackways because preservation favors soft ground and because populations actually wander into the new mosaic. Bias matters, but it is signal too. Persistence makes fossils because it makes burial gentle, often. Winners here are not superheroes. They are flexible. Wide diets, broad thermal and moisture tolerances, gates that do not bog on soft floodplains, sprawls that spread weight, toes that splay, limbs tucked under bodies that can step clean through muck. Early theropods fit. Protosauropodomorphs reach into the new canopy. Crocline predators split niches between still pools and sluggish channels. Turtles run a calm, armored clock. In humid modes with oxygen dips, breadth beats edge case specialization. Regions still shape the score. Some basins hold rhinchosaurs longer, maybe riding local dry windows between humid bursts or perched on sandy highs. Some carbonate shelves keep patchy platforms where runoff stayed weaker or currents kept clarity. High-latitude hints show cooler pockets that soften the punch. But zoom out and the same staircase repeats. Disturbance and fern spike. Conifer rise. Wetlands spread. Picky lineages thin. Generalists and small, adaptable forms multiply. This is where the Dinosaur Diversification Event hums a first verse. Not giant sauropods stomping yet. Not blockbuster apex hunters. Seeds. Small, adaptable clades find room and time. Habitats mosaic. Pressures shuffle. When pulses ease and the long breaks cool the floor, those lineages already stretch across distance and niches. Opportunity first, then scale. Reframe extinction here. It is pruning by weather habit. The stall, not a single blast, does the trimming. If your life cycle needs the old on-off drought rhythm and the off never arrives on time, you bleed ground. If you can breed and feed through months of damp, dark, and detritus, you gain it. The sky chose a side by staying. The record shows death by mismatch and rise by range. Humans miss the shape because we chase bang events, but this is the one we feel. Slow resets that hit the same lanes, floods that return before drywall is dry, shelves that choke again before currents clear them, animals and plants answering in increments. That is the Carnian lesson written in tracks and spores. And there is one more edge. Preservation bias is not a cop-out, it is the climate speaking. Soft ground makes more prints. Gentle burial saves more bones. Black mud saves more shells and wood. So of course we see more of certain groups. They also truly expanded because only expanding puts you where mud can keep you. Both are true. The rock is not lying. It is weighting the story toward the world that won. So count the winners. Turtles, crocodile archosaurs, small mammaliaforms, early dinosaurs with range, fish with low oxygen tricks, amphibians that ride linked wetlands, insects that mine litter, plants that colonize fast then hold shade. Count the losers, dryland specialists, picky carbonate reef builders, thin-shelled high-oxygen swimmers, sprint-end-weight predators of cracked flats. That is the ledger a parked sky writes. Which brings us back to the now. Persistent wet does not just rot roads. It rewires who lives where, who eats what, and which maps keep their shape. The Carnian shows the path from cull to crown. If habit sets, generalists inherit the lanes. If habit shifts back, the deck reshuffles again. But while the sky stays, it plays favorites. The fossils are just the receipts. The forgotten Cataclysm problem. Here's the thing, an event that flipped climate, oceans, and life should be front row, but the Carnian wet turn got sidelined. Impacts steal the spotlight. One rock, one crater, one bad day, clean story, 2 million years of rain, sounds like weather. Weather sounds small, so the narrative slipped. Textbooks locked it in. Teachers need anchors they can draw in chalk, the Permian collapse and the Cretaceous impact. The Carnian sits in the awkward middle after recovery before dinosaurs get huge. Worse, it refuses to be a spike. It is 4 pulses paced by orbits, shoved by Wrangellia, amplified by water. Not a tidy chart, a network. Research silos kept the pieces apart. Sedimentologists logged smectite flips and varve stacks in the Alps. Paleobotanists mapped fern spikes and conifer surges in basins. Geochemists tracked sharp negative carbon isotope dives. Volcanologists dated flood basalts welded to western North America. But the zipper was missing. You could argue local river change for each outcrop and walk away. Mercury changed that. It falls out from the sky, not down a single valley. When labs began pairing mercury organic carbon spikes with ash shards and carbon isotope plunges, the beats clicked across China's lakes, western Tethys shelves, even high latitudes. 4 pulses, 4 dives, 4 flips to humid. The global baton finally showed. Naming hurt too. Carnian Pluvial episode, humid intermezzo, wet phase, a muddle of labels. Skeptics waved it off as a regional quirk, but consistency wins. Same clay pivot to smectite, same carbon isotope pattern, same black shales, same biotic reply, fern spike, conifer rise, wet gild spread. Not everywhere on the same day, but everywhere in the same sequence. That is a system, not a storm. Our villain bias made it worse. We want a single trigger. The Carnian says, sure, here's the match, Wrangellia, but timing and map magnified it. Orbits leaned summers hot over land. Pangea trapped moisture against tall rims. Sulfates changed cloud seeds. Oceans capped and fed vapor highways. Forests leaked water and roughened the air. It is a lattice of pushes and locks. Harder to headline, truer to earth. Noise gave cover for years. Some basins stayed patch dry between pulses. Antarctica hints at cooler pockets. A few faunas lingered longer than models said they should. Those exceptions looked fatal to the case, until the clocks sharpened. Astrochronology pulled the 405,000-year metronome from mud bundles. Uranium, lead, and argon tightened ages. Lithium and osmium isotopes flagged fast weathering and mantle fingerprints. Mercury isotopes leaned volcanic during spikes. The crosscheck stacked. Local storms do not pace 4 continents on orbital beats. We also underrate wet. Droughts get lore, famines, dust, exodus. Floods are cast as a hit and run. The Carnian flips that story. Persistent wet is not background. It is a driver. It strips oxygen from shelves. It revs weathering that drags carbon down over long spans. It moves continents of mud and builds black shales that cut the greenhouse later. It prunes picky lineages and lifts generalists. It turns maps into mosaics. That is not a lot of rain. That is a mode. So why does this matter now? Because the shape matches our pain. Not everything, everywhere, all at once, enough, often in the same lanes to feel like a habit. blocking highs that refuse to budge, atmospheric rivers that retrace a wee-cold groove, basins that never quite dry between hits, shelves that go breathless twice in a month. Those are not plot twists. They are a pattern you can pre-plan for if you admit it exists. Media habits need a reset. The hook is not doom, it is recognition. Mercury spikes in Triassic mud show a sky learning to stay. The same mechanics warm oceans, weak jets, seeded clouds are stacking again. That sentence lands because it carries receipts. Hand samples with ash, geochemistry with names, models with maps, and then footage that rhymes. Parked lines, rotting roads, hypoxic fish kills after warm, wet runs. People feel the bridge. Academia is catching up. Synthesis papers now stitch Wrangellia's pulses to global mercury signals and carbon dives. Climate models tuned to Triassic geography show jet weakening and stalled monsoons on a warm floor. Paleoecology maps the winners and losers across humid lanes. But syllabi lag. So do planners. The Carnian belongs in climate risk briefings next to El Niño and blocking climatology, not in a footnote under Triassic miscellany. There's one more blind spot: fear of nuance. Viewers think nuance kills stories. I disagree. The Carnian wins because it is a clean arc made of parts. Match, feedback, stall, rewire, break. That is a story spine you can feel at street scale. You do not need to memorize isotope codes to use it. You need to know what to watch, persistence, not peaks. So let's pull it forward with 3 plain rules. 1. Pulses prime, habits hurt. Focus less on the biggest crest and more on how often lanes reload. 2. Maps matter, rims, valleys, and shelves decide who gets taught the lesson first. 3. Receipts beat vibes. Clay flips, mercury spikes, and carbon dives made the ancient case. Today, ocean heat, blocked days, saturated soils, and repeated hypoxia make the modern one. Stack 3, move early. Because this is the real warning. The Carnian is not a prophecy. It is a manual. The sky learns habits. Land and sea help keep them. If we ignore that shape, we will keep calling stalls unprecedented until they rewrite our maps. If we accept it, we can shave the peaks, pad the lows, and shorten the run. That is the difference between a wet season and a wet era. The echo in today's signals. So does this shape show up now? Start with the ocean. It is loaded with heat, not just the top inch. Layers down. That stored energy keeps feeding vapor into the air day and night. More vapor means heavier storms when they trigger and thicker atmospheric rivers when pressure lines form. You can see the plumes on satellite. Long, bright threads. Same lanes, week after week. They do not just hit, they park. Blocks are the steering wheel stuck left. On a warmer floor, the jet weakens and meanders. Ridges sit. A dome parks over one region and bakes it. On the rim, storm trains ride the same corridor. Europe felt that, heat under the block, floods along the edge. The western United States watched rivers in the sky slam the same coastal ranges again and again. Burned scars turned to mudslides in hours. Not a fluke, a pattern with receipts. Hydrology tells the truth between headlines. Base flows are rising in many basins. Rivers stay high even between systems because soils never fully drain. When the next burst comes, there is no sponge left. Floods spike faster. Urban grids crack first. Drains built for a big day do not handle a soaked month. Storm and sewer lines crosstalk. Backflow hits basements. Substations drown because the plan assumed one crest, not 3 in 10 days. That is the operational face of persistence. Monsoons are wobbling in the way the Carnian logic predicts. South Asia throws heavier bursts, odd pauses, then reloads. North American monsoon fingers reach farther north some summers, then hang back and retrace. When belts hesitate over rough, warm terrain, afternoons light up along the same lines. Valley winds and urban heat boundaries feed them. Lanes copy themselves. Coasts whisper, the ocean echo. After warm, wet spells, shelves bloom, then turn breathless near the bottom. Hypoxia shows up sooner and stays longer. It clears, then comes back after the next runoff pulse. Offshore, stratification caps mixing and traps heat in a thin, hot skin that evaporates hard. That fattens the next plume and pushes it back at the same shore. It is not black shale time, but the loop is the same shape. Warmth, runoff, bloom, low oxygen, reload. Aerosols flip the story in a way you feel but do not see. Cutting sulfates cleans the air, which is right for lungs. It also lets more sun reach warm water and ground right away. Evaporation jumps. Meanwhile, smoke from fires and dust from drought-still seed clouds. That mix can delay rainout and build taller anvils over hot surfaces. Net effect in many regions. Clearer blue, stronger downpours, longer soaks. Compound hits show the feedback. A hot spring dries forests. Fire cooks soils hydrophobic. Then a parked plume dumps for 4 days. Water skims, shoves ash and soil into rivers and slams a coast already warm and stratified. Blooms flare, oxygen dips, fish die. Surface water warms more. The next storm rides in on thicker vapor. One chain, many steps, no pause. Land use leans on the levers. Cities throw heat, smooth wind, and speed runoff. That can sharpen local convergence and push training lines to the same avenues. Clear-cut hills lose roughness and midday transpiration spikes. Clouds may start later, but floods peak harder when a stalled belt arrives. Reforest, and you raise evapotranspiration and roughness, which can cool peaks, mix the boundary layer, and stretch cloudy windows while trimming extremes. Patch that across a continent, and you shift where the copy machine runs. Big ocean modes tilt the lanes. El Niño on a record-warm baseline fattens Pacific plumes and drives them poleward. The Indian Ocean dipole decides who takes the hit around its rim. If the Atlantic overturning circulation slows, heat release slides and pressure patterns bend. Blocks hold longer in odd places. Add meltwater freshening to polar seas and you lock in stratification that feeds strange winter jets. None of these is a switch. Together, they are rails. Here is the caution flag. Similar is not same. We are not on Pangea. Orbital phases today aim seasonal sunlight at different land masses. But the mechanics rhyme. Warm floor, fat vapor, weak steering, seeded clouds, rough or slick land, capped shelves. If storms retrace last week's path, if soils stay above the soggy line, if rivers hold high between crests, and if coastal hypoxia returns before it clears, you are brushing the loop. So watch for persistence, not just peaks. Stack tells, ocean hot pools across basins. Verified blocks holding 10 days or more. 2 or 3 atmospheric rivers reusing a corridor. Root zone moisture above the 75th percentile that refuses to drop. Base flows climbing. Repeated blooms and oxygen dips after wet, warm runs. 3 of those dials up. Move a tier early. Open storage. Stage pumps. Pause planting. Preposition outage crews. Spin up microgrids. You are buying time against habit. Mindset is half the fight. Stop calling every parked line unprecedented. Start calling it what it is. A warm ocean, weak jet, seeded cloud stall. The Carnian is not a doom scroll. It is a manual for modes. The sky learns habits. Land and sea help keep them. Our job is simple to say and tough to do. Lower the fuel, rebuild the sponges, and act on persistent signals before the map changes under our feet. The trigger stack, not a single switch. So what actually flips a region from rainy to parked wet? Not a single lever, a stack. In the Carnian, eruptions shoved, orbits leaned, continents focused the hit, and the water cycle did the rest. Today, the sources differ, but the mechanics rhyme. Greenhouse gases build the floor. Aerosols tweak cloud seeds. Oceans store heat and feed vapor. Land use reshapes where and when water returns to the air. Big ocean modes bend storm rails. Stack enough of those and storms stop traveling. They sit. Start with the floor, carbon dioxide. It is the slow, steady push. We keep adding it. The air warms. The ocean soaks up most of that heat, then pays it back as vapor every hour. More vapor raises the ceiling on how intense storms can be. Add methane. Short-lived but strong. Bursts from wetlands in hot years, thawing permafrost and fossil leaks stack a decade-scale boost on top of the carbon dioxide climb. That background alone fattens the water cycle. It primes the sky. Now the aerosol twist. In the Carnian, sulfur from volcanoes briefly cooled surfaces and showered the air with cloud seeds. Today, we are cutting sulfate pollution, which is right for lungs and rain chemistry. But dropping that reflective veil lets more sunlight hit warm water now. Evaporation jumps. Meanwhile, smoke from fires, dust from drought, and sea salt in stronger winds still seed clouds regionally. The net in many basins is a paradox, a higher greenhouse floor with enough nuclei to delay rainout and build taller anvils. Cleaner skies, stronger downpours, storms that sit. Layer in land use, forests cleared or regrown, wetlands drained or rebuilt, cities that throw heat and speed runoff. Vegetation controls evapotranspiration, the quiet leak of water back to the sky. Clear a forest to crops or pasture and you lower roughness and change the hour clouds flip on. Pave a valley and you warm surfaces and shove outflows toward the same convergence lines. Reforest and you raise humidity, mix the boundary layer, and stretch cloudy windows while shaving flood peaks. None of these flips climate alone. Across a continent, the patchwork nudges monsoon belts, shifts convective corridors, and favors training storms along heat and moisture boundaries. Oceans and ice set the rails. Warm pools in the Pacific and Indian Oceans steer atmospheric rivers. When El Niño stacks on a record-warm baseline, those plumes thicken and lean poleward. The Indian Ocean dipole decides who takes the hit around its rim. Over the Atlantic, the overturning circulation places the main heat release. If it slows, pressure patterns bend and jets meander. Meltwater freshens polar seas, caps mixing, and feeds odd winter blocks. Sea ice loss dulls cold season gradients, which some analyses link to more meanders and stalls. Here is how a stack
None of
becomes
these
a stall
is
on the
destiny.
ground. Together,
A basin heads
they load
into
the
summer
dice
with
with a hot offshore pool. The jet is weak and kinked by a blocking ridge. Atmospheric rivers line up along a narrow pressure corridor and aim at the same mountains. The first hits saturate soils and raise base flow. With each pass, downdrafts are moist and do not kill nearby updrafts. They lift them. Land breezes and canyon winds seed new lift at night. Cleaner skies over a high greenhouse floor keep evaporation raging offshore. Smoke from distant fires and dust from drylands add enough cloud seeds to slow rainout and loft taller anvils. The line sits. That is a regional lock-in. Now the nutrient kicker. Parked storms do not just move water, they move fertilizer. Fields and streets leak nitrogen and phosphorus into swollen rivers. Coasts bloom, then turn breathless near the bottom. Stratified hot skins sit offshore and evaporate hard. That fattens the next plume and pushes it back at the same shore. It is not a black shale chapter, but the loop matches the old shape. Runoff, bloom, low oxygen, stronger vapor lines. Orbital phase still hums underneath. Precession and eccentricity bias seasonal heating over land. You cannot feel those clocks day to day, but they lean monsoon strength by region. Catch a few decades when geometry favors hot summers over your landmass. Add a warm ocean, a weak jet and seeded clouds, and you lengthen wet runs and stalls. It is not a prophecy. It is a tilt. So list the modern trigger stack in one breath. Elevated greenhouse gases plus fewer reflective sulfates on top of record-warm oceans, with land-use mosaics that reshape evapotranspiration and runoff, plus big ocean modes and meltwater that bend jets and storm tracks, sometimes leaned on by orbital phase. That ensemble can park storms regionally for seasons. You do not need a million years to feel it. 2 soak years can break levees, rot transformers, and erase a decade of farm math. What breaks it back? In rock time, slow breaks, silicate weathering, organic burial, ocean overturn. In real time, managed breaks, cut the fuel, carbon dioxide and methane so jets strengthen and vapor thins. Rebuild sponges so water can pause without harm. Wetlands, floodplains, mixed forests, permeable streets. Strip nutrients off flood paths so coasts do not feed the next plume. Harden grids and drains for duration, not just peak. And watch the stack form. When ocean hot pools align, blocks verify, soils hold above the soggy line, base flows rise, and coasts choke twice in a month, you move a tier early. The stack is the switch. Catch it before it clicks. How the loop ends, natural and managed breaks. So what actually loosens a sky that learned to stay? In rock time, Earth leans on slow, blunt tools. Silicate weathering is the big one. Warm rain hits fresh rock, especially basalt, grabs carbon dioxide and turns it into bicarbonate that rivers ship to the sea. Later, it locks into carbonate minerals. It is chemistry as thermostat. The hotter and wetter it gets, the harder it works. But it is a 1,000-year lever. During the Carnian, it mattered only after the volcanic pulses eased. Black mud is the second break. When seas go low oxygen, more organic matter escapes decay and sinks. That is carbon leaving the fast loop and parking in shale. It helps, eventually. In the short term, burial happens because the system is already hot and wet, which means the weather engine keeps running while the receipt prints. Oceans have a mechanical reset too, overturn. When surface waters cool or get saltier, they sink, dragging oxygen down and pulling nutrients up. That can end local anoxia and thin the surface heat cap. But you need strong winter cooling and winds. With a high greenhouse floor and fresh lids from heavy rain, overturn weakens. You wait for seasons that are not showing up. Biology adds a softer break. As forests mature, canopies change how water moves. Big trees lift water high and leak it back slowly. Understory thins. Midday transpiration spikes flat. Litter rebuilds soil. Infiltration rises. Runoff smooths. Floodplains fatten and spread peaks. None of this shuts rain off. It makes hills and rivers fail soft instead of snapping. Over long spans, resilient canopies also lower fire risk and keep roughness that mixes the boundary layer without supercharging storms. Volcanic pacing is the meta break. In the Carnian, pulses kept shoving before slow levers could catch. When the pulses faded, weathering and burial trimmed the greenhouse floor. Jets strengthened a bit. Storm tracks began to walk again. Shelves breath. The loop did not quit in a day. It sagged as long breaks pulled the background down. We do not live on geologic clocks. Our breaks must be faster and managed. The only lever that scales is cutting greenhouse gases. Lower the floor and the whole storm engine loses fuel. That means slamming carbon dioxide down this decade, not in a pretty future. Clean power fast, build transmission, electrify heat and transport, efficiency everywhere. Then methane because it hits hard on short spans. Plug leaks in oil and gas. Capture landfill gas. Cover lagoons. Manage rice and manure smarter. Protect and restore peatlands so they do not flip to sources in hot drought. People ask aerosols next. Stratospheric sulfate would, on paper, cool the planet. It would also shift rain, change chemistry, and leave oceans acidic. And if you stop, heat jumps. So if that lever is ever touched, it must be slow, governed, and paired with deep cuts. Safer plays live local and tactical. Brighten marine clouds over brutal marine heat waves to spare coasts. Seed fog to save redwoods. Cool cities with reflective roofs and cool pavements. Think nudge, not hack. Nature-based breaks are not vibes. Reforest where water budgets allow, with mixed species that burn less and transpire in ways that cool without supercharging floods. Restore floodplains and wetlands as sponges along rivers and coasts. They slow surges, store water, strip nutrients, and rebuild soils that hold through soak. In cities, build sponge layer, parks, bioswales, permeable streets, tree canopies, cisterns. You are not changing the sky. You are buying drain time and shaving peaks, so a parked week is survivable. Nutrients are a quiet fuse you can cut. If heavy rain is the new normal, stop feeding blooms. Precision fertilizer, cover crops, riparian buffers, floodplain reconnection, and wastewater upgrades that do not overflow at the first crest. Keep phosphorus and nitrogen on land, and you break the runoff. Bloom. Hypoxia loop that warms shelves and fattens the next atmospheric river. Grids need wet breaks too. Elevate and seal substations. Add floodwalls and sump paths as standard, not add-ons. Loop feeders so one drowned valley does not black out a region. Put storage at hospitals and water plants. Microgrids that island, then rejoin. Hydropower can flex like a battery if reservoirs are managed for flood space and power peaks together. That is rules and telemetry, not just concrete. Farms move with the sky. Shift calendars where onset slides. Trial wet-tolerant varieties and rootstocks. Raise beds where it pencils. Drain tiles where it must, but pair tiles with field-edge wetlands so you do not export floods and fertilizer. Spread risk. Perennials on slopes, wet-foot crops in low spots, aquaculture where ponds hold, mussels and oysters where coasts clear. Insurers meet them halfway with parametric triggers that pay on rainfall duration and river height, not paperwork after rot. Timing is everything, so watch persistence, not peaks. Build a dashboard that flags ocean heat, blocking days, stacked atmospheric rivers, root zone saturation, rising base flow, repeated coastal hypoxia. Tie each tier to moves you practice. Open extra storage, pre-position pumps, slow traffic on landslide routes, pause planting, stage payouts, spin up microgrids. Publish the playbook so people know why you move. Education makes the break real. Teach park storm physics in middle school. Show how wetlands work. Let locals log pond levels, seepage, mold blooms, fish kills. Those crowd signals sharpen thresholds by basin. Replace unprecedented with Park Jet Day 15. People act on patterns they understand. Plain truth, we cannot stop rain. We can stop the lock, cut the fuel so jets strengthen. Rebuild sponges so water has places to pause. Trim nutrients so the coast does not feed the next plume. Harden the systems we count on so a wet month is a story, not a scar. In the Carnian, the loop ended when the pulses faded and the thermostat caught up. Today, we choose how long we keep shoving. Lower the shove and the planet's slow breaks can meet us halfway. Leave it and they arrive too late. What changes us if it starts again? So if the sky tips into parked wet, what actually changes first? Drains, roads, and power, because they were built for peaks, not weeks. You stop designing only for speed. You design for storage. Bigger culverts with trash racks you can clear fast. Deeper sumps under intersections. Overflow parks that take water on purpose and bounce back. Streets that drink, permeable pavement over gravel beds, so lanes don't turn into rivers. And yes, separate storm from sewer so toilets don't geyser when a river crests twice in 10 days. Power has to climb out of the basement. Substations get walls, flood doors, and pumps as baseline, not extras. Switchgear goes on steel and concrete stands. Control rooms move upstairs. Loop feeders so one drowned valley doesn't black out a county. Bury lines where fire meets flood, but pair that with fault isolation so a short doesn't cascade. Build microgrids around hospitals, water plants, and shelters that island during storms, then rejoin cleanly. Put batteries on high ground. Hydropower rules change. Hold flood space and still flex for peak demand. That's telemetry and operators, not just concrete. Homes adjust in stubborn, boring ways that save money. Utilities get raised. Backflow valves are code. First floors use materials that dry and don't mold. Tile, lime plaster, removable baseboards. Ground level parking under raised living. Porches you can hose. Sumps with alarms that text you. People keep a wet kit. Boots, masks for mold, a box fan, a HEPA filter, a sensor for humidity, a way to drink roof runoff. Boring is survival. Food bends next because calendars break first. Plant by onset, not tradition. Pick varieties that handle heat and wet feet together. Shorter roots, thicker stalks, quick maturity. Raise beds where it pencils. Lay drain tiles where it doesn't, but feed them to field-edge wetlands so you don't just export floods and fertilizer. Contour swales and hedgerows that slow water and pin soil. Perennials on slopes. Wet-foot crops in low spots. Aquaculture where ponds hold. Mussels and oysters in cleaner, buffered estuaries. Insurance has to meet that reality with parametric triggers. Pay on rainfall duration and river height, so farmers can move while rot is still soft. Cities become sponges because hard edges shatter under soak. Pocket parks as sumps, bioswales on long blocks, curb cuts that feed street trees. Roofs catch the first inch and a half, then trickle to cisterns. Neighborhood tanks feed toilets and fire trucks. Floodplains stop being parking lots. They become fields and courts that can drown and dry. Transit stays up. Raised stations, sealed conduits, pump sumps on tunnels, bus lanes that double as evacuation routes. And a new rule: 2 independent ways in and out for every hospital and substation. Finance and insurance must admit persistence. Retire the myth of the 100-year line. Price for duration. Lower premiums if a building raises gear, adds floodwalls, or stitches wetlands into its footprint. Public backstops fill in where private markets bail. Maps update fast, and they track stacked storms and blocks, not just a peak crest. Mortgages price water risk honestly so people don't buy into traps they cannot exit. Governance changes cadence from headline to playbook. You set thresholds tied to a dashboard. 3 atmospheric rivers in 12 days on saturated ground with a verified block. Tier 2. That unlocks gates. Open extra reservoir storage. Stage pumps. Slow traffic on landslide routes. Pause planting advisories. Move backup power. Trigger fast payouts. It feels bureaucratic until it saves a town. Publish the playbook so people know why you moved before the crest. Public health gets wet savvy. Mold clinics stock box fans, HEPA filters, and antifungals. Shelters add dehumidifiers. Vector teams track mosquitoes after long soak. Pharmacies keep extra insulin, antibiotics, and blood pressure meds for weeks when roads are out. Heat plans blend with wet plans because humid heat kills. Cooling centers double as dry rooms where people can beat mold and charge phones. Culture shifts to rain windows. Schools keep remote days that are practice, not chaos. Work schedules slide around storms. Festivals move a month because onset moved. Construction tents pours and cures. Sports fields swap base layers to drain. People move tools upstairs before forecasts, not after. It's not fear, it's rhythm. There's also a chance lens. Water abundance is value if you hold it. Roof to barrel, barrel to cistern, cistern to park, park to aquifer. Industry cools with stored rain, not river pulls in drought breaks. Street trees shave heat and mop water. Floodplains, once reconnected, grow wet crops and store carbon. Jobs follow the shovel where you knit green to gray. But hold on, retreat has to be real and dignified. Some valleys will see parked lines too often. Buyouts that are fast, fair, and optional. Builders get pointed uphill by incentives. Codes lock out basements in flood zones. The map changes because the sky did. That is not defeat, that is strategy. Communication finishes the pivot. Stop saying unprecedented. Start saying park jet day 12. Tell people what to watch for in their zip code. Retracing storm lines, soils that never drop below soggy, rivers that stay high between crests. If those stack, move early. It will feel strange the first few times. Then it will feel like choosing. And none of it works without cutting the fuel. Emissions down now. Clean power, wires, heat pumps, transit, methane leaks plugged. Wetlands and forests restored where they cool and sponge. Nutrients kept on land so coasts don't feed the next plume. We are not trying to stop rain. We are trying to stop the lock. Lower the floor. Build the sponges. Act on persistence. That's how you keep a season from becoming a mode. Monitoring the edge. The early warning dashboard. So here's the move now. Watch persistence, not just peaks. Build a dashboard that treats stuck wet like a mode you can spot early and blunt before it writes mud into maps. Start with the fuel, the ocean. Track global ocean heat content, not just the skin. When integrated heat rises and the Western Pacific warm pool, the subtropical North Pacific, and the Indian Ocean are all hot at once, flag it. Those are vapor launch pads. Hot pools stacked across basins mean thicker, atmospheric rivers, and longer fetch. Layer the big ocean rhythms on top. ENSO tilts the near-term board. A strong El Niño on a record-warm floor fattens Pacific plumes and nudges them poleward. La Niña shifts corridors and can stretch wet seasons in different basins. The Indian Ocean dipole sets who gets hammered around its rim. Over the Atlantic, watch the overturning proxies. Subpolar heat content, Labrador sea density, Gulf Stream strength. If the Atlantic meridional overturning circulation slows while subtropics stay hot, pressure fields bend and blocks hold longer. Not prophecy, probabilities. Now the sky's chemistry. Track regional sulfate aerosol optical depth. If sulfates drop fast while greenhouse forcing is high, more sun hits warm water now and evaporation jumps. Watch smoke and dust too. Use satellite aerosol index and particle size, because those are cloud seeds that can delay rainout and build taller anvils. Add methane. Satellite columns and isotopes tell you if wetlands or fossil leaks surge. Methane hits hard on decade scales, so a bump means near-term shove. For the stratosphere, watch water vapor, because it nudges jets and radiative balance. Hydrology is where persistence shows its face. Root zone soil moisture is your quiet tell. Use satellites, models, and ground probes. If big areas sit above the 75th percentile for weeks and do not relax between systems, you're pre-locked. Rivers confirm it. Track base flow and flashiness. Rising low flows with shorter gaps between crests means the sponge is gone. Floods ramp faster. Count atmospheric rivers by corridor and strength. There are catalogs for integrated vapor transport and landfall intensity. When counts stack over the same lane in one season, step up a tier. Wind shape is next. Monitor blocking with simple public metrics: Greenland blocking index, Pacific ridge persistence, days with verified Rex blocks. Put parked domes on a live map. Overlay ensemble storm track density so people can see belts retracing last week's lane. When a block verifies for 10 days and guidance holds another week, assume stall until proven wrong. That single call buys time. The biosphere is a cheap, honest sensor. Pollen networks catch fern spikes after floods, fast colonizers that love wet gaps. Tree pollen timing shifts tell you calendars slid. In water, satellite chlorophyll flashes blooms. Pair that with dissolved oxygen buoys at depth. If hypoxia returns weeks after clearing, you're looping. Add coastal fish kill reports and jelly blooms as boots on the water confirms. They hit before lab plots post. Now turn dials into triggers. Build stacks, not single lines. Tier 1 could be this: regional ocean hot pool above the 90th percentile plus 2 atmospheric rivers in 10 days. Tier 2 adds root zone moisture above the 75th percentile for 21 days and a verified block. Tier 3 folds in repeated coastal hypoxia and rising base flows that fail to drop between storms. Each tier unlocks moves you've rehearsed. Open extra reservoir storage, pre-position pumps and portable flood walls, pause planting advisories, slow traffic on landslide routes, stage parametric payouts, and spin up microgrids to island critical loads. Crowd signals close the gap. Give people a simple app. They log basement seepage, culvert overtops, pond levels, outfall surges, mold blooms, and fish kills with a timestamp and a photo. Those are hyperlocal persistence flags. Hand out cheap rain gauges, soil moisture probes, and door height flood markers. Feed it into the map with light checks. Locals tighten thresholds by basin, not by the whole state. Governance must be wired in, or the dashboard is wallpaper. Assign owners to each dial. Water utilities work storage and sewer gates. Transportation closes slopes before they slip. Health departments push mold advisories and stock HEPA filters. Agriculture extensions text field guidance tied to saturation days. Insurers flip fast-track payouts when rainfall duration and river stage cross preset lines. Publish the if this, then that playbook so people know why you moved before the crest. Scale it right. National dashboards set the frame, ocean heat, ENSO blocking, but decisions live regional. A hot Indian Ocean means different work in East Africa than Western Australia. Each basin sets its own cut lines based on what fails first. After each wet season, hold a short, blunt after action. Update thresholds with what broke and what held. Retire dead metrics. Promote ones that predicted pain. Power runs on shared language, so talk it plain. Swap 1 in 100 year for 3 storms in 12 days on soaked ground. Replace unprecedented with parked jet day 15. People act when they recognize the pattern. The goal isn't to predict a million-year rain. It's to catch the mode while it's still a season, so you can blunt it before it becomes a habit. And here's the kicker. The ancient stones gave us the dials: pacing, priming, parking, persistence. We just turned them into a dashboard. Now use it. Here's the claim you can fact-check in rock. It didn't just rain more. Earth flipped into a wet mode that lasted on the order of 1 to 2 million years. Receipts fast. Identical clay-rich laminae appear in basins an ocean apart. Volcanic ash pins the same horizon. Mercury spikes ride those layers, the global tracer that falls out of the sky, not down one river. Carbon isotopes plunge 4 separate times. Lakes and shelves go breathless and lay down black mud. Right after, life reshuffles in the same order. That's a system turn, not bad weather. Name the engine. Wrangellia, a large igneous province erupting in pulses. It lofted carbon dioxide, sulfur, ash, and metals into a world with Pangaea's leverage. Mercury to organic carbon ratios jump exactly where carbon dives across the western Tethys, South China, even high latitudes. 4 pulses, 4 dives, 4 humid surges. That is pacing, not coincidence. Flip lived in the sky. Carbon dioxide raised the floor. Warmer air held more vapor. Sulfate aerosols seeded clouds with too many tiny droplets, delaying rainout. Delayed rain meant taller anvils and weaker steering. Freshly weathered basalt darkened soils and added grit that tuned ice in cloud tops. Vegetation leaked water back all day and lowered the lid on convection. Oceans capped with warm, fresh skins that evaporated harder. The jet weakened and blocked. Storms retraced yesterday's path. That is the hydrological feedback trap. Stakes land here. When rain becomes a habit, it rewires winners and losers. Dryland specialists thin. Picky carbonate reef builders stumble. Ammonoids take hits in oxygen-poor water. Generalists surge. Turtles, crocline archosaurs, small mammaliaforms, and the first adaptable dinosaurs. That is the Dinosaur Diversification Event's opening verse, born from persistence, not a single blast. Why should you care now? Because the rhyme is loud. Ocean heat content is record high. Atmospheric rivers keep reusing the same corridors. Blocks park. Rivers stay high between storms. Coasts hit hypoxia after warm, wet runs. Cleaner skies from fewer sulfates boost surface heating even as smoke and dust still seed clouds. Land use tilts where clouds pop and which valleys train. Not the Carnian again, but the same shape. Warm floor, fat vapor, weak rails. The journey we're on in this episode is simple and sharp. 1. Trace the rock receipts to the volcanic engine and its pulses. 2. Show how chemistry became cloud physics and locked the sky. 3. Watch life bend, who thins, who spreads, and why. 4. Pull the echo forward and build a dashboard that catches persistence before it writes new maps. You'll leave with a checklist, not a vibe. Pacing, priming, parking, persistence, and the moves that blunt a mode before it sets. By the time the pulses faded, storms had learned to stay, water had learned to linger, and life had learned to live with it. That same physics is in our lanes now. If this clicked, subscribe and share it with someone who still calls every stall unprecedented. Drop the one signal you'll watch in your region below. We're turning your notes into a living early warning map, so people can move early, not after the sirens.